Introduction to Islands of Manufacturing Automation. In this video, we are going to see about Introduction to Islands of Manufacturing Automation. Automation is an evolutionary concept rather than a revolutionary concept. Since this historic development, rapid progress has been made in automating most aspects of manufacturing. While numerical controls evolving on its own, computers were being developed self-sufficiently. Though computers were initially introduced in manufacturing to support business functions, that is such as payrolling and accounting, over the years computers have become an integral part of manufacturing. Now computers represent the brain of the automated manufacturing. Developments in manufacturing technology. 1998. A global manufacturing based on virtual CIM. 1990. Concept of virtual CIM introduced. 1980. Advanced systems in CAM, CAP, CAQC, ASRS, FMS, etc. and SIM. 1970. Developments in CAD, application of CAM-based systems and introduction of the concept of SIM. 1955. Beginning of CAD and development in NC such as CNC, DNC. 1950. Early developments in NC for automation. 1940. Very large mass production system. 1930. Mass production systems. 1900. Mechanization and early factory systems. 1750. Craftsmen. 1600. Manual and animal labor. It may be noted that till 1970s, all the developments in manufacturing technology took place in complete isolation. The technology focused on few aspects of manufacturing in isolation. Say, the NC and CNC machines are developed to improve the manufacturing productivity. AGVs and robots are developed and used as material handling equipment. By the early 1980s, the importance of integrating these islands of automation had been realized. However, over these years, the difficulties of integrating these islands of automation have been addressed. As a result, the dream of computer-integrated manufacturing has been made reality. If the various islands of automation are integrated or interconnected with each other, then the resultant system is known as a computer-integrated manufacturing system. SIM represents the logical revolution of the islands of automation concept. Since the islands are not capable by themselves to bring out a big picture of the entire manufacturing activities, the evolution of SIM has become a natural evolution by the integration of these islands of automation. Various islands of automations, which by integration forms computer-integrated manufacturing, include flexible manufacturing systems, that is FMS, group technology, that is GT, computer-aided design, that is CAD, computer-aided process planning, that is CAP, computer numerically controlled, that is CNC machines, computer-aided manufacture, that is CAM, manufacturing resource planning, that is MRP2, robotics, automated material handling systems, that is AMHS, computer control systems. The each and every technology in isolation represents an island of automation. For example, CAD is an island of automation. FMS is another island of automation. If all the above technologies are interfaced, then they form a SIM system, that is, integrating all the above technologies, SIM is developed. Information flow in SIM. SIM elements without mainframe computer and resulting islands of automation. Computer integrated manufacturing, that is CIM, through mainframe computer. This figure illustrates the concept of island of automation and how the integration using mainframe computer forms a SIM system. Introduction to CAD. In this video, we are going to see about Introduction to CAD. CAD is a term which means Computer-Aided Design. CAM is a term which means Computer-Aided Manufacturing. It is the technology concerned with the use of digital computers to perform certain functions in design and production. This technology is moving in the direction of greater integration of design and manufacturing. These two activities, which have traditionally been treated as distinct and separate functions in a production firm, ultimately. Computer-aided design can be defined as the use of computer systems to support in the creation, modification, analysis or optimization of a design. CAD systems. Hardwares. Systems softwares. The CAD hardware typically includes the computer, one or more graphics display terminals, keyboards and other peripheral equipment. The CAD software consists of the computer program to implement computer graphics on the system plus application programs. Examples of these application programs include stress-strain analysis of components, dynamic response of mechanism, heat transfer calculations and numerical control part programming. The collection of application programs will vary from one user firm to the next because their product lines, manufacturing processes, and customer markets are different. These factors give rise to differences in CAD system requirements. Necessity of CAD. In this video, we are going to see about necessity of CAD. To increase the quality of design by reducing design and analysis errors, to decrease the time required for design and analysis, to increase productivity of the designer, to upgrade the quality of the design, to boost communications, to build a design database. Benefits of CAD: improved productivity, more accurate design, reduced lead time, cost saving in tool design, flexibility in manufacturing, design changes can be easily accommodated. staff required for design department can be reduced. Low design cost. Overall design productivity is found to increase 3 to 10 times. Design, drafting, documentation errors are minimum. Majority of calculations are done by computer. Design procedure can be converted to standard formats. High quality drawings are possible. More number of drawing viewports. Realistic 3D images. Stages of CAD. Ideally, a designer should consider all these factors while designing a product. Problem identification and recognition of need, problem definition and conceptualization, geometric modeling and spatial analysis, engineering analysis and optimization, prototype analysis and optimization, manufacturing process development, manufacturing implementation. CAD software. CAD software will normally translate data from different file formats and inputs, that is, systems linked through CAE, so that different applications can share information in the database. Types of CAD software. AutoCAD, SolidWorks, Solid Edge, MicroStation, Aliber, CATIA, Pro Engineering, ANSYS, NISA. CAP, that is Computer-Aided Process Planning. In this video, we are going to see about CAP, that is Computer-Aided Process Planning. During the last several decades, there has been considerable interest in computer-aided process planning, that is CAPP, automating the process planning function by means of computer systems. Sharp people knowledgeable in manufacturing processes are gradually retiring. An alternative approach to process planning is needed, and CAP systems provide this alternative. Computer-aided process planning systems are designed around either of two approaches: retrieval systems, generative systems. CAM, that is Computer-Aided Manufacturing. In this video, we are going to see about CAM. Computer-aided manufacturing can be defined as use of computer system to plan, manage, and control the processes of a manufacturing plant through either direct or indirect computer interface with the plant production resources. CAM tool consists of CAD tools, networking integration and automation concepts, and manufacturing tools. By combining both the design and manufacturing with the business functions, the industry can be automated completely. Needs of CAM: to increase labor productivity, to reduce labor cost, to improve worker safety, to improve product quality, to reduce manufacturing lead time, to accomplish processes that cannot be done manually, to mitigate the effects of labor shortages. Activities of CAM: manufacturing support activities, cost estimating, computer-aided process planning, machinability data system, production and inventory planning, development of work standards. Functions of CAM. In this video, we are going to see about functions of CAM. The functions of computer-aided manufacturing include two categories. They are manufacturing planning and manufacturing control. Manufacturing planning. During this process, the computer is used in offline to deliver required information for providing effective production planning and management. This production planning and management includes CAP, that is Computer-Aided Process Planning. It concerns with the route sheets preparation, and this route sheets list the set of operations and work centers which is needed for producing the products. Computerized machinability data system. It concerns with the machinability data generations like feed, speed, and more. Development of work standards. It concerns with standard time generation for job. Estimation of cost. It concerns with the production of total product cost. Production and inventory planning. It includes the maintenance of automatic stock items, recording, inventory records, maintaining priorities, etc. Computer-aided line balancing. It concerns with the work element allocation with assembly line stations. Manufacturing control. Manufacturing control is the computer system application that is used for managing and controlling the physical operations. It includes process monitoring and control. It concerns with the observation and regulation of production equipment and manufacturing process. Shop floor control. It concerns with the collection of data from plant operations, and this data is used for controlling the production and inventory. Quality control. It concerns with several approaches that is used for ensuring the maximum possible quality levels. Inventory control. It concerns with the maintenance of inventory for reducing the investment, cost of storage, and to increase the customer service. Just-in-time production system. It concerns with the item delivery to customers or to exact machines at the required time. CAI, that is Computer-Aided Inspection. In this video, we are going to see about CAI, that is Computer-Aided Inspection. Computer-Aided Inspection, that is CAI, and Computer-Aided Testing, that is CAT, are the two major segments of computer-aided quality control. Whereas these activities have been traditionally performed manually, CAI and CAT are performed automatically using computer and sensor technology. The implications of the use of computer-aided quality control are important. The automated methods of CAQC will result in significant improvements in product quality. The following list summarizes the important benefits of CAQC. With computer-aided inspection and computer-aided testing, inspection and testing will typically be done on a 100% basis rather by the sampling procedures normally used in traditional QC. This eliminates any problem in assembly later and therefore is important in CIM. Inspection is integrated into the manufacturing process. This will help to reduce the lead time to complete the parts. The use of non-contact sensors is recommended for computer-aided inspection and CIM. With contact inspection devices, the part must be stopped and often repositioned to allow the inspection device to be applied properly. These activities take time. With non-contact sensing devices, the parts can be inspected while in operation. The inspection can thus be completed in a fraction of a second. The online non-contact sensors are useful as the feedback element of adaptive control systems. These systems will be capable of making adjustments to the process variables based on analysis of the data, including trend analysis. An example of the application of trend analysis can be found in the compensation of gradual wear of cutting tool in a machining operation. This would not only help to identify out of tolerance conditions but also to take corrective action. By regulating the process in this manner, parts will be made much closer to the desired nominal dimension rather than merely within tolerance. This will help to reduce scrap losses and improve product quality. Sensor technology will not be the only manifestation of automation in CAQC. Intelligent robots fitted with computer vision and other sensors as an integral part of completely automated test cells is also a feature of SIM. An important feature of QC in a SIM environment is that the CAD or CAM database will be used to develop inspection plan. As mentioned earlier, inspection can be either contact or non-contact type. The contact method usually involves the use of coordinate measuring machines, that is CMM. Coordinate measuring machine. The coordinate measuring machine, that is CMM, is the most prominent example of the equipment used for contact inspection of parts. When used for SIM, these machines are controlled by CNC. A typical three-dimensional measuring machine consists of a table which holds the part in a fixed position and movable head which holds a sensing probe. The probe can be moved in three directions corresponding to the X, Y, and Z coordinates. For manual operation, the control unit is provided with joysticks or other devices which drive X, Y, and Z servo motors, that is AC or DC. During operation, the probe is brought into contact with the part surface to be measured and the three coordinate positions are indicated to a high level of accuracy. Typical accuracies of these machines are in the neighborhood of plus 0.004 mm with a resolution of 0.001 mm. The measuring accuracy of a typical CMM is quoted 2.6 plus L by 300 micrometers, where L is the measured length in millimeter. Levels of automation, that is automation pyramid. In this video, we are going to see about levels of automation pyramid. Automation pyramid. ERP, Enterprise Resource Planning, MES, Manufacturing Execution System, SCADA Network, Supervision Control and Data Acquisition. Following 10 levels of automation describe all the present machineries and those will be invented in future. Order of automation. Human attribute replaced. Examples: Level 0, none, lever, screw, pulley, wedge. Hand tools, manual machine. Level 1, energy, muscles replaced. Powered machines and tools, Whitney's milling machine. Level 2, dexterity, self-feeding, single cycle automatics. Level 3, diligence, no feedback, repeat cycle, open loop numerical control or automatic screw machine transfer lines. Level 4, judgment, positional feedback, closed loop, numerical control, self-measuring and adjusting. Level 5, evaluation, adaptive control, deductive analysis, feedback from the process, computer control, model of process required for analysis and optimization. Level 6, learning by experience, limits self-programming, some artificial intelligence, that is AI, expert systems. Level 7, reasoning, exhibits intuitions, relates causes and effects. Inductive reasoning, advanced artificial intelligence in control software. Level 8, creativeness, performs design unaided. Originality. Level 9, dominance, supermachine commands others. Machine is master.